Literally no response.
Sounds legit to me.
Sounds like something you teach.
It is legit. It's a, let's see, is a gallery of My Little Pony avatars. Here's our endpoints. Of course, in the context of Heroku. All right. Now, since it's on the slide, it's on the test. Anybody want me to cover anything before I talk about our last couple little topics? Go ahead.
Conversion questions.
Are you serious? Didn't you see my video on
Slack.
Slack? I give a crash course. Oh, you're good at conversion though, right? Ish. If you don't know how to convert yet, A, shame on you, but B, there's a crash course on like a 10-minute video on a general channel on Slack that shows you the two patterns and that stuff. What else? Anything else you want me to review or talk about or anything like that based on what will be on the exam? We're all good? All right, so I want to talk about the last couple of interprocess communication types that we've mentioned, at least one of them passively in here, but I want to talk about the last one just to kind of complete the idea of interprocess communication stuff. One thing you've probably seen before, it's used pretty commonly in a lot of applications, and this is this idea of file locking. How many of you ever heard of seen something that says you couldn't get file lock or saw that phrase file lock or something like that using some application? Seen that before? So what do you think that probably means, file locking, as a form of interprocess communication? Go ahead.
It means that somebody else has locked the file that you're attempting to access.
Okay.
And so you can't use it because they're using it.
Now,
In terms of like a Unix, a POSIX system would be within the whole communication thing because since everything's a file there.
yeah. So really that can mean two separate things. So you can have, because really what we're doing is file locking would be almost a form of a semaphore. In fact, it's usually implemented in terms of semaphores. All right, so you would lock a file, which then allows other people to, well, here, let me ask this. Assuming file locking is implemented in terms of a semaphore, which means that it's atomic, right? You try to grab the baton, if you will, yet you aren't able to get it. What's one weakness of a semaphore? If you have three people all vying for the same one resource, there's a distinct weakness with semaphores that actually does not exist with file locking. You possibly might not have enough information to answer it, but we'll see if somebody can come up with it in the next 10 seconds or so. When you have several resources trying to talk to a semaphore, how do you know when you get the resource? If you're that thread or you're that process that's talking to the semaphore, how do you know that you've gotten into the critical section? Or how do you know that you're not in the critical section? What is the critical section? What does that mean when I say critical section? You can go back to the My Little Pony API. Somebody, not Emma. What's the critical section?
That's the section you need the resource for.
Yeah, it's the part that we're protecting, right? A couple lines of code in there that the semaphore is locking down. How do you know that a thread or a process has gotten access to the critical section? It starts executing the critical section, right? You don't have this opportunity to ask, are you waiting in line for the resource? That makes sense? With semaphores, we just say, look, fight to the death, and we're going to let that bouncer handle it. and then the internal semaphore system decides whether it's going to let you loop back, or how long until your next attempt to break down the door, or something like that. And eventually you should get in by their something called deadlock, either deadlock prevention, deadlock avoidance, deadlock resolution, for how do you handle this idea of deadlock, which is effectively when a race condition occurs. All right. So now, file locking we can think of as being similar to a semaphore, in that you grab a file atomically, but file locking allows you to find out that you were turned away from the door. Okay, because you're accessing this through the normal file I/O system. So you can try to open a file atomically using the file locking subsystem, which is probably implemented on POSIX systems as a semaphore. Yet you then get to decide when you're going to try to grab it again. There is a default model for letting it automatically decide for you to grab it again, but the reality is you can decide. You can say, am I able to grab the file lock? If yes, you might make a decision based on that. In fact, that's kind of the second part of what we're going to talk about today. But this idea of file locking is fairly common, even though we've talked about semaphores, and it seems like it sort of kind of solves the same problem. Now, something that Emma pointed out is there's kind of two uses of file locking. One is legitimately locking a file because you want to protect writes to the same file. Because we do already have an issue when a file is read from the hard drive and loaded into memory, the current version of the file gets loaded into memory, right? So if person A is editing that file here and person B also opened the same version of the file here in memory, whoever writes last is going to be the new version of that file. So you very well might want to limit who can open a file for reading, not just who can open a file for writing. Because the person who's reading it may not have the most up-to-date version of the file. Does that make sense? But now you also have to consider that if you're in a system where somebody might have a file open for an hour, maybe don't want to lock other people away from having that file. So that's where you look into possibly an event-driven system where a file updates. We kind of see that with like Google Documents. If you're in a Google document that you're sharing with lots of people, you'll see like in there the little colored thing that so-and-so is editing this, and you actually see it happening in real time, so you know that things are changing. So that's more collaboration environment. So you're seeing some modern day solutions to that problem. So you do have one issue with that where it's whoever writes last wins when multiple people are reading the same file. But more often than not, file locking is being used as a alternative bouncer to a resource, which may even be another file. So you could certainly use file locking or use a semaphore to protect a file. So you might say I'm going to use a semaphore when I don't necessarily have to know whether I was rejected or not. You might use file locking when you might want to do some additional type of logic in between when I tried to get the resource and when I actually got the resource. It gives you those opportunities to make some decisions. So it's almost an enhancement to semaphores because it's typically implemented in terms of a semaphore. It just gives you the kind of the callback that you failed. Tried the doorknob, didn't work. That kind of thing. All right, makes some sense for file locking. So we can kind of see where that might fit in if we did want to make some decisions there. The other thing, which let's talk about design patterns again. Over the course of your 4 years here, let's say, we've talked about several different design patterns in my classes. What are the ones that you recall? There's kind of three that I bring up over the years. The one that I'm talking about here is probably the one you're not going to remember because it's the one we talk about the least. Go ahead. MVC. Okay, what's MVC?
Model view controller.
All right. And what's MVC?
Modular programming, so you can create different
It's a good idea to separate Logic from your interface. Just keep going, man. Cue cards. Okay, so MVC effectively says it's a good idea to have your logic in one place, your interface in another place, and kind of your database in another place. Keep those things in separate places, just from an organization thing. It is the modular programming type thing, but with some other good stuff sprinkled in there. All right, so what's another one? I'm afraid you might say the wrong one first.
Probably not.
All right, go ahead.
A singleton?
Good. All right, so what's a singleton?
It's where you basically have only one instance of the object or class or whatever that everybody accesses.
Kind of a shared global resource, easy to take advantage of, almost breaks the traditional kind of go-to saying that global variables are bad. But realistically now with object-oriented programming, and especially when we have multi-process type programming, sometimes global variables are necessary. We had that effectively with shared memory in here with a lot of our inter-process communication. Is sometimes you got two guys, you need to get information between the two of them. A lot of times a singleton is a good solution for that, but it also can, actually let me ask, did you guys use a singleton in your project? Did you find yourself, in the end, do you feel like you used the singleton correctly, or do you feel like you maybe abused the singleton and put too much stuff in it?
I feel like we probably used it correctly.
Okay.
It was very simple. It was like some of the stuff about our current user that we were tracking.
Okay. Did you use the singleton in yours? Same question.
It was a lot of like methods for interfacing with the database.
Okay.
Wrapper methods.
So did you feel like you used it for only stuff you really had to use it for?
Yeah.
Okay.
Like database references to the
Sure.
like the key.
Yeah.
database.
One risk you have with singletons that is pretty common as projects get larger and larger and larger, and you really need to be careful about it, because this is almost the reason why we have that global saying that global variables are bad, is because singletons are very convenient, you get into this habit of just putting everything in the singleton, where you decide, well, I'm never willing to spend the time of, like, you take Android as an example, of putting these two variables in an extra to pass it to the next activity.
That's the worst.
Okay, because it seems tedious, right? But if only that next activity needs that information, or even maybe if only two other activities need that information, it might make more sense to encapsulate it in that little logic area than have this like random thing that's used by one activity up in your singleton. Yet it always happens because it's so convenient, right? That's like it's the strength and the weakness of a singleton, is how convenient it is, and at the same time how easy it is to abuse.
You showed us that one Xcode project, I think like 300, where didn't they have like over 1,000 lines in there, or something ridiculous like that?
Right, but it wasn't. I showed it to you in 300. Yeah. So that was one of my projects where where I abused the singleton. Part of that wasn't really my fault, because that project was created through, it was like a web thing where I was training somebody. So that was over about a year period where we would have like sessions once or twice a week. And he thought he wanted it this way, then all of a sudden you go back to this way. So sometimes you're like wrapping duct tape on a problem, right? Like, okay, now you want this screen and this screen to have something. Well, I can go back and possibly break 600 other things, or I can just throw a quick variable here and get it over here, and life goes on. So sometimes it's out of necessity, but the final version of that, though, is a good example of where it can be abused, right? So fine, I did it, again, out of convenience and maybe even out of necessity, because it was safer to do that than possibly break code, because you had there was something like 200 different classes in that project, where there's a lot of things that potentially could break because it wasn't well planned. We didn't follow good software engineering stuff, so pay attention to 370. But singletons can easily be, taken advantage of. All right. Third, last one I probably mentioned in class. Give you a hint. It's related to a concept I'm about to talk about in here today. Starts with an O. What did you say? Observer. The observer design pattern. What does that guy say?
Pretty much you have a method or a function
Okay. I think you know what it means. I'm not sure that's a great. I'm gonna actually put the definition for this one in here since we haven't heard that one very often or since maybe a long time. Anybody else want to take a stab at a better definition of the observer design pattern? This really comes down to this idea of asynchronous communication, multi-threading, multi-processes, things we've really focused on in here, but we've talked about in other classes.
Notify me when something interesting happens, right?
Yeah. So,
Firebase.
yeah, kind of. Firebase is a great implementation of the observer design pattern, and Firebase forces you into it, which is sometimes actually problematic. How many of you had previously worked with Parse? Might have been you were right there when it went out, when they shut down.
In the watch programming class, remember that?
Yeah.
I think we used that.
And that like in the middle of the semester, that's when they shut down their operations. So then we switched to Firebase, which I think is the better I think is the better product now, and certainly Google agreed with that when they bought it. But I might say that if there's one weakness to Firebase, even if this would most of the time be poor programming practice, is you cannot make a synchronous call to the database. Usually you don't want to. Usually you don't want to. But going back to last week, when we were looking at Annie's code, it would have benefited us to be able to make a synchronous call to that database. We would have had our answer and known after we have it, we can do the next step, right? That would have benefited us. You can't do that with Firebase. So Firebase forces you to do everything asynchronously, which let's call it 99.9% of the time is what you want. That's good programming practice. And it is an exact implementation of the observer design pattern. The observer design pattern says it's a good idea to keep busy while waiting for some event to occur and then be notified when said event happens and respond accordingly or something like that. And accordingly, I guess we could have gone with Van spelling for that. Man, yeah, he butchered a couple of those slide titles.
Demotation.
Well, yeah, and advice. Like you said, advices or something like that, yeah. You would think the squiggly red line under your title would give you the... Yeah.
Do you think that Firebase doesn't give people a syntax to make synchronous calls because they think that people will do it incorrectly, or that...
Well, okay, now we're speculating on their motivation. I think a good answer might be that you could always make an argument for them not to do it. I think that there's never is a really tough word to use, right? It would be very, 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 very likely that there is an asynchronous approach to your problem that you're looking for the quick and dirty synchronous approach to, where you don't have anything else to do. Maybe you're your own thread, and all you have to do is wait for this data. Give it to me synchronously, I'll wait. That way you don't have to write the handler and things like that. Now, having said that, though, I do think certainly for less experienced programmers, the idea of the asynchronous callback can be somewhat intimidating. And when you see that option of having to write a lot of code versus, I can just get my answer right here, you kind of go with this one because it appears easier, even though the performance is drastically hurt by a synchronous call. But if you literally have nothing better to do during that period of time anyways, then you might ask yourself, are you implementing your solution correctly? But at the same time, I think there is a time and place every now and then for a synchronous call. Parse allowed for both. You could, I don't even know if I would say the default, but you got to choose whether you wanted to make the call asynchronously or synchronously, and you would kind of use the right one for the job.
Because there was a time where I wanted to make a synchronous call, and I think that maybe it's a good thing that they don't offer it, because there was a time where I wanted to make a synchronous call on a project that was related to the user populator stuff. So I realized that I could force it to be synchronous if I wanted to, but then I realized that there was probably a reason they didn't let me, or they didn't let me. So.
Yeah, so at the end of the day, I think you can make a significantly stronger argument for them never letting you make a synchronous call than you could make for them technically allowing you to make a synchronous call at the risk of allowing bad programmers to make, or inexperienced programmers to make bad decisions, based on their inexperience. So I don't think it's necessarily a problem. Okay, but the idea here is with the observer design pattern, which, remember, design patterns are conceptual ideas, not necessarily implementations, right? We've seen Android's version of the MVC implementation. We've seen, Xcode's version of this. We've seen Unity's version of this. Whatever it is, any modern IDE has their own take on MVC, and this kind of almost started maybe with like Ruby on Rails, where they built in their own MVC, because prior to that with PHP, it's like, hey, we have really ugly looking .php files because websites are becoming a bigger thing than just a simple site that has some text and a picture on it. So as those things got bigger, we started needing to separate those things because it looked like a pile of junk. All right, so again, the observer design pattern is just an idea. And the idea is if we have lots of threads, we have lots of processes, whatever it is, they can be doing other things while they're waiting for something to occur. With the Firebase example, you said, look, Firebase, I need some information from you. And so then then you go on and you do something else, and when Firebase is good and ready, it sends you that information. You guys benefited from it specifically with the chat server. So that's where the connection to what we did in here is. We architected the whole thing. We didn't finish the whole thing. But punchline is you could understand that writing a chat server, as boring as that sounds, is actually fairly difficult, right? Firebase does one magical thing that makes chat servers easy. It allows you to subscribe to an event, and it says, let me know when something in the database changes. So now when somebody chats, all they have to do is write to the database. Database handles the rest. Lets everybody else who's interested know, right? Calls their little callback function, and then on their app, you can spit stuff to the screen, right? It makes that, it's that the magic sauce for that solution to that problem. So that would be a good example of the observer design pattern. So Firebase gives you the choice. So maybe under common circumstances, you're saying, let me know when you have the data. In fact, with Firebase, you can say, I only want to know once. That way you're not taking up system resources constantly listening. You can say, look, I want to grab the current version of this, this reference once. Give it to me, and then I don't want to be notified again. That's good enough for me. But then you can also say, whenever stuff changes, or whenever something's deleted, or whenever something's edited, or whenever something's added, you can, you kind of choose your story. Let me know. I want the opportunity to potentially update my interface or make some changes or do something like that. So you have those options. That's really what the observer design pattern says. It says, give me a mechanism, create a mechanism for letting interested parties know that something has occurred. Simple enough? Okay, makes sense in real life too. If you're waiting for the bell to, we don't have, how come there's no bells in college? Do they still have bells like in high school?
Yeah.
Class is over, you wait for the bell, right?
But the bell doesn't dismiss you, the teacher does.
Oh, really?
That's what all the teachers say.
Yeah. Just such a bad one-liner. Can't handle it.
It doesn't
Yeah.
make sense, because if the bell didn't dismiss us, why are there bells?
Yeah. Now, maybe it's a thing in college, even though I'm not sure all teachers do this, but you're all adults. You got something better to do, just go. We were talking last night, like the other day, if you didn't like we were working on the Heroku problem, just go up, get up and go. Who played this out? Who knows, right? After that class is over, I got to talk about signals first, and you can bail, I guess. But yeah, so in any case, this whole idea of letting interested parties know about things really it started with this idea of event-driven programming, where and if you've done stuff with Visual Studio, double click on the button and it says on button click or on button press, whatever the name of the auto-generated function is. Make this happen when somebody clicks the button. Okay, but that's more of a manual type of thing between a human physically doing something and the code directly behind that, where Firebase adds one additional layer. Where you have the server pushing out to many potential endpoints, anybody who's registered with that and said, look, I want to know. All right, so we would call Firebase a pretty modern approach to that, right? It's one of the things that's really good about Firebase, and also maybe, like we said, the thing that's kind of frustrating about it sometimes. But we have this idea that's been around for a long time called signals. All right, so signals are effectively OS-wide. I'm going to put it in quotes. We can say events, but it really isn't an event. It's almost like a shout with a string attached to it. So signals are implemented as being very generic. There are some built-in signals in the system, but then you can create a signal that effectively says anything. So you can have so effectively you can think of signals like this. You can have apps that are interested in hearing a signal, and then you can have apps that are interested in raising signals, and some apps might have both, right? So an app that raises a signal might say, I'm done, basically yells, okay? Operating system wide. Now, other apps, whether it's a thread or a process, whatever it is, they can tell the operating system, I want to know about the I'm done signal that this dude's going to be screaming about. Let me know when that occurs. So you kind of are registering with that event. So, this idea of signals really is a fairly simple idea that we work with in real life, correct? So if you go to the movies and somebody yells, hey, I'm over here, you become notified, whether you liked it or not, that the person that you were meeting there is over there, and now you congregate or whatever it is. Now, in some of our more modern things, did you guys deal with anything? While I've already mentioned that Firebase is kind of an example of the observer design pattern, it is more complex than signals, because you're not just... It actually probably isn't super fair. It really is a signal. It's just giving you a nice package of results with it. Because typically, the traditional signal doesn't come with data. The traditional signal comes with a screen.
So in the JavaScript framework that I worked with called Dojo, there's topics that's essentially, I think, what you're describing with the signal, where it's you subscribe to it and you determine in there what you want to. And I don't think that maybe you can, but I don't think that you typically associate data with them.
Yeah. Most modern implementations of signals typically will let you package an object, and you can make that object whatever you want, because that is convenient, right? Sometimes you want to scream and throw something too at the same time. So did you actually use any of those event-driven things? So other than Firebase, did you use any sort of signal type stuff in your application? Okay. Did you use anything? You were in iOS.
Would that be like, so you can subscribe to notifications for like when the keyboard appears, and you want to move your stuff up so that like the text fields aren't covered? That's an example of that, right? Yeah,
and that uses NS Notification Center, right?
Yeah, the notification center.
Yeah. So on iOS, let's look at it in terms of the My Little Pony thing, I guess. We have NS Notification Center. which existed back with Objective-C. So this has been around for a while. So notice here we're adding observers. Now you can add an observer, a selector is like your callback function, whatever. So kind of the same thing we've seen with Firebase and that kind of stuff. But there's this overarching notification center called the default center. So this is almost the iOS, which is an operating system that has provided, although notification center does not work across apps. Although I think they have one that works across apps now. And I don't know if it's done through NS Notification Center or not. Because now the apps can technically run simultaneously. You can have one app notify another app if you kind of have sister apps that are, a good example might be like on my phone, I use like the MyFitnessPal thing. And my Google Fit app or something notifies him when like new exercise is recorded. So it updates. And now that was always kind of a thing on Android because Android has always just been a Linux operating system where all the apps are just running and draining your battery. Well, so that's where you had the apps come out for killing apps on Android, and Apple always bragged about good battery life because you had, only the app that was in your foreground was getting battery time unless it was written by Apple. And had their magical hooks into the OS. Well, then all of a sudden the batteries got a whole lot better, and now it's like, okay, well, the people who are Android users like the fact that they could play their music at the same time as they're browsing the web or something like that, where that wasn't a thing on the early iPhones. And then Apple kind of made like a little kind of a hack for it to hook into like the audio system or something like that, so technically music apps would do their thing. But now Apple has stuff that'll actually, your apps can run in the background because they figure, batteries are good enough now. Android's gotten better at their management. Apple's decided to let's be a little bit more like Android from letting multiple apps run at the same time, getting real CPU power. And battery life just is kind of the same across the board for these different devices now. So I think that Apple, and I forgot the name of the thing, but it's something with Notification Center. It might actually be the standard NS Notification Center. Will let two apps talk to each other, where Android probably accomplishes this through Java's Notification Center. It's not even an Android-specific thing. And I'm not positive on that. It's called as 78%. So more than 3/4 sure, but not, don't take that to the bank, I think. But the punchline is all these things are examples of that observer design pattern where you need more than one thing to know that something has occurred, with the modern benefit of being able to pass a piece of information. Now, does that mean that if we go back to, if we're talking about it in Linux, a lot of these things are not stuff that was invented 5 minutes ago? Signals in Unix have been around way longer than any of us have been around. All right, so even older than me, probably older than Dr. Locklear. Or close. I mean it's a race condition. So signals do not allow you, although it's possible in modern versions of Linux, specifically since these things are now under the GNU license, it's possible there are versions of signals that I'm not familiar with, haven't used, but that do allow you to package something along with it. But for the purpose of this conversation, let's say that they don't. Let's say that a signal only allows you to scream, raise some flag. Hey, over here, I'm done processing, whatever it is. And then, 5 or 6 other threads, whoever they are, that could say, I'm interested in hearing about that. Does that mean that we cannot get information to those other threads or those other processes? How would you accomplish that? If Annie's a thread and she's doing her, maybe it's a merge sort type thing or something like that. So let's say that all of you are threads working on the merge sort problem. If we want to be really fast, you're actually multiple processes running on multiple CPUs, possibly across multiple machines using like message passing interface or something like that. But you're multiple threads for this argument. So, the list keeps getting split in half. We're doing merge sort. So each of you is sorting your own little tiny thing. You know, you got the kind of the lazy people in the back that get the one lists and just done. Right? So they don't have to do any merge, but then, you know, it kind of splits from there, right? Okay, so now ultimately, so let's say I was the original process. Ultimately, I finally hear back from, let's say, the original 2 threads that you guys are done. You raise your signal. How do I get my data? How do you send that to me? How do you send me your partially sorted list? And how do you send me your partially sorted list? Let's presume that we weren't dealing with a shared pointer necessarily. You know, we're using specifically an example of merge sort, which would benefit from that. But you've done some work, and you have your solution right here that you're like, I'm done, but I need to deliver this. And you said, I'm done, but I need to deliver this. How do you get it to me if signals don't support that? Somebody, not Emma. It's something that you don't need me to have taught you today. This is a prior to today issue. What problem are we solving? When you scream and say you're done, what problem are you really solving there? What are you doing? In real life, if we're supposed to meet at the movie theater and I walk in and you go, hey, over here, well, you're notifying me that you're there, that you're ready, whatever it is. Okay? So that's the problem you're solving with signals, right? Just telling someone else that, sending them a quick message. You can hide the message and whatever thing. My brother used to use an example of signals back when. Do people still make collect calls? They're not a thing anymore, are they? Does anybody know what a collect call is? First of all, does anybody not know what a collect call is? Because this story is kind of based on that. So back when you still had payphones, if you didn't have change for the payphone, you could make a collect call to somebody. And the person would get the call and ask, like, are you willing to accept the charges? It's a call from that. Well, my brother, being cheap, he would take advantage of the system. So this was like before he had a driver's license and things like that. So when he was done playing tennis or something, he would make a collect call to my mom, and it was an automated system. So my mom would get the phone call and it was like, do you accept a collect call from Pickup Dave? And then he would just trust that signal was delivered. No money was, no, that's signals. That's it. You think I'm cheap. This is another one of those things where some of the Jewish stereotypes. When my brother was in college, he used to crash pizza parties just for he had no idea what the party was. There was pizza there, just go in. Free pizza. And he'd go back for seconds and thirds and things like that. His nickname on his tennis team in college was Mooch. When you mooch off people. Right? I mean, this was a kid whose dad was a dentist, right? I mean, it's not like he was fine, but instilled at a very young age, I suppose. But yeah, so that's an example of signals, all right? So that's the problem we're solving when you say you're done. But now, how do you get me the payload, the information that you have for me? We have a second problem to solve now. You've let me know that you're done, which means that, whatever I was doing, remember with this observer design pattern, the idea is that I can be busy doing something else. And then all of a sudden, Annie interrupts me and say, hey, over here, I'm done. That then kind of, startles me and says, okay, I can choose to handle that right now, or I can finish what I'm doing right now. But at the very least, I have now, if somebody calls up and says dinner's ready, you might finish playing your video game for 3 minutes and then go down, but you've been notified that dinner's ready. Okay? So, how do we solve the problem now for her to get me the data that she needed to share with me? Last day of class. Let's engage our brains, people. This is not a hard question. Spent a good portion of the semester since the midterm talking about interprocess communication. What is interprocess communication? If you had to give me a global, generic definition for interprocess communication, what might you say?
Two or more processes speaking with one another.
Exchanging information between two or more processes. So one kind of information we can do is a signal thing where we're screaming and that's it. Okay, what's another example of interprocess communication that we've worked with? Start listing them. What's our examples of interprocess communication?
Shared memory.
Okay, shared memory. What does that guy do?
It's kind of like the Singleton, where everybody has a reference to the same bucket.
Shared memory. So this is share the same stuff between two or more processes / threads. All right, what else? What other IPC have we worked with? Sockets. I'm going to say sockets / pipes here. It's kind of the same thing, except one's local, one's not. What are these guys for?
Basically allow you to pass data or whatever between one and the other.
Kind of a string-based communication, right? It's almost like making a telephone and maintaining that connection. So, two-way communication over a stream, data stream, something like that. All right. What other kind of interprocess communication do we talk about? We've mentioned these guys today. We've only talked about 2 topics today. We've talked about signals and we've talked about not My Little Pony. So the other one. Which is an example of semaphore type stuff. All right. So, semaphore, say file lock. Okay, what's this guy for? What's he the right tool for the job for? I think it was a dangling preposition, whatever.
Kind of like granting access or showing when to grant access.
Yeah, protecting the critical section, protecting a resource. Let's say limiting access to a resource that is race condition aware or something like that. Solves the race condition problem because it's atomic E stuff. All right. Any other ones? We looked at it. We had a working example. We didn't incorporate it into any of our programs, but we could have for our chat server. We looked at message queues. Okay, so message queues similar maybe to kind of shared memory, but they were organized differently. Kind of like we can think of like shared memory more like a linked list, where it's a generic thing, whereas maybe well, as its name indicates, a message queue is like a queue where you add things to the end and you remove things from the front. You can only use it a certain way. Okay, so maybe it's its own little thing here. So maybe we call this organized, self-organized sharing of. I'd probably call this real time because there really is a real time solution to issues. we were looking at it maybe for our chat server for when multiple things need to know what are the current messages. So organize sharing over real-time, I don't know, solutions or something like that. All right, so at the global scale, that kind of covers some of the, the inter-process communication that we've done, which really covers all the inter-process communication that exists in operating systems. Now, some of these can be exploded into like 2 or 3 different subsystems for handling this, that some have, like similarly, like file locking and semaphores are kind of the same thing, but different ones have like little features that may or may not benefit you, those kinds of things. So depending on the operating system, you might have more or well, you'd have at least these, we'll call these almost primitive types. But then beyond that, you might have special versions of these guys. Do any of these look like it would be helpful for you to get your data to me? Which of these?
I would say sockets.
Sockets? Okay, possibly. You can make sockets work. I think sockets might be a little tough in this situation because if we want to think about this in real life, I don't know how busy you are. Okay, so you might yell that you're done, but maybe now you're off doing something else. If we're doing a real life example of this, when you yell you're done, the socket example would be I now call you up, expecting you to be sitting by the phone waiting on me so that you can share your data with me. A viable solution, but maybe not a good solution.
So shared
But
memory.
yeah, probably. Yeah, that solution is certainly better than semaphores for this. Maybe shared memory, maybe even message queues, but if we haven't talked about the nature of what the data you have is. So yeah, shared memory.
Didn't you tell us to pretend that didn't exist?
What didn't
I
exist?
thought you told us to pretend that shared memory didn't exist a couple minutes ago.
No, I said pretend like a shared pointer
Oh. Okay.
doesn't exist. Maybe you interpreted it as shared memory, that we weren't sharing the same pointer. But I can see how you might have seen it the other way. Okay, but otherwise you could have said message queue. That would be reasonable enough as well, because that'll allow you to share almost anything. Just who cares if there's only one thing in the queue? But the idea is you scream, and then that lets me know to go check our secret spot, right? Because the idea is you would have put your output up there, then you scream, which lets me know that I can go get the payload. That make sense? Similarly, maybe she does the same thing, and probably when we started this, you guys knew about individual pointers because you put your half of the list shared in one place, you put your half, and I merged the two together into a single solution. All right, so does that kind of make some sense? All right, final exam is Friday at 10 a.m. Is that correct? Okay, like I said, if you need to take it earlier, the earliest I'll be back on campus is, let's say, Wednesday morning. But let me know and we can work something out. But otherwise, if you're going to be here anyways, just wait till Friday. All right, I will see everybody, I guess, next Friday. Good luck on your exams leading up to that.